The last couple equations we looked at, we were solving by factoring. Now this one is going to be a little different. This one's going to look like we want to solve it by factoring, but we are actually going to use a quadratic equation on this one. So let's go ahead and solve it for x. Since they are not specifying degrees or radians, we will go with radians. And we're going to list all of the solutions. We're not just going to do one rotation. We are going to have to list all the solutions by adding 360 or in this case 2 pi around, or cosine will be 2 pi every time. All right, so let's go ahead. Let's take this equation, and I am going to distribute the cosine into the parentheses. So we're going to have cosine squared x plus 2 cosine x. And I'm going to subtract 1 so it equals 0. Now, if I want to look at this one and go, okay, are there any factors, anything that multiplies to give me -1 and adds to 2 so I could factor? And that answer is no. But this equation looks a lot like our standard quadratic equation. ax squared plus bx plus c equals 0. My x, though, is the entire cosine term. So this, my x here is cosine squared x plus 2 cosine x minus 1. So we see that we have an a of 1, b equals 2, and c equals -1. What are we going to do with that? Well, we're going to plug them into the quadratic formula. Quadratic formula says x equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. So hard not to sing it. Okay, but it's not going to be x equals. It's going to be the cosine of x is going to equal all of this when we plug it in. So we're going to say the cosine of x equals -2 plus or minus the square root of 2 squared minus 4 times 1 times -1 all over 2 times 1. So I'm going to get -2 on the outside, plus or minus 2 squared is 4 plus 4, all divided by 2. Continuing to work, I'm going to get -2 plus or minus the square root of 8, all divided by 2. Let's simplify that square root of 8. Square root of 8 is 2 radical 2, all divided by 2. So the cosine of x, the cosine of some number, equals, everything divides by a 2, is going to equal -1 plus or minus radical 2. All right, so this is... Now what we're going to do is we need to find the inverse, because what we're saying is the cosine of some angle in radians is this value. Well, we need to find what the radians are. So to find the radians, we are going to do inverse cosine of -1 plus or minus radical 2, and that's what my angle will be in radians. Well, if we put this, let's put this into a calculator. -1, I'm going to do it in order. -1 minus radical 2. You know, let's go up here. Let me go. If I simplify this, I'm going to simplify -1 minus radical 2, and we're going to do -1 plus radical 2. So -1 minus radical 2 gives me -2.4142, and -1 plus radical 2 gives me 0.4142. When we're taking the cosine, when we want to find the inverse cosine of this, what we're saying is adjacent over hypotenuse is this long. Well, that can't work. -2, the biggest this could be is less than 1. So this one is out of our range. We're not going to plug that one in. The only one that we can figure out is this one. This is greater than 1. It's 1 or greater, so it doesn't work. Let's use this one. Cosine and sine have to be less than 1. And I am going to put that into my calculator because I don't know the exact value. And we are going to find out that x is about 1.1437 radians. Now, so if we're looking at this, that means cosine is positive in quadrant 1 and quadrant 2, and 1.1437 radians is in this quadrant. So that is a reference angle of 1.1437. Well, if we can go up 1.1437 radians, we can also go down 1.1437 radians. Well, how are we going to find that value? Since we're doing radians, to find out where I am on this one, I'm going to do 2 pi minus 1.1437 radians, and that is going to give me 5.1395. So x is also about 5.1395 radians. Alright, my instructions though were to find all of the solutions. So my first solution is going to be at 1.1437 radians, and again this will happen every full rotation of my unit circle. So we're going to add 2n pi, and we can also be 5.1395 radians, and again we are going to add 2n pi, where, because I'm finding all of the solutions, so we're going to keep going around the circle, and we specify that n is an integer because it could be positive or negative. Boom. So that took a little bit longer, but I think it was worth it. That's kind of fun to see the quadratic formula used in a different type of way. So if you got any questions for example 3, come on in and let me know.